Okay, so we left off last period. Okay, you look up here. These are your claims. We just went over those. Don't need to do them again. I'm going to take these pretty much one by one over the course of the next few days and try to show you how some of the stuff in that video is correct and some of it is completely fabricated and some of it is exaggerated. All right, and try to so you understand the difference between it. Okay, and at the time, some of it wasn't necessarily done intentionally. I'm not saying when that graph first came out, he even said this is the first time anybody outside a small circle of scientists has seen this particular graph. When they were first measuring this, we didn't really have the ability in the very beginning to measure with the precision it's going to be necessary for me to explain something to you that's absolutely essential to this debate. If there was a debate, of course there isn't a debate. There's just me and everybody else in the world against me. That's not true. There are quite a few people, but they'll tell you that there's no one else debating this. All right, let's start with the very first statement. CO2 drives temperature change. Okay, let's look at that. That seems to be the most important thing. Obviously, if that is true, and we are pumping, and those other graphs are true, like here's CO2 now, and here's where it's going to be in 40 years, that's scary stuff. All right, that's really, really scary stuff. Well, let's talk about that. Well, I'm going to give you about 4 arguments, I think, underneath this. Some are better than others. One is absolutely essential. This first one's it's an okay argument, but it is an argument. It's something that people don't often realize. Okay, even without knowledge of the science behind this, this is a pretty decent argument. Because here's the deal. Turns out that CO2 is only 3% of all the greenhouse gases. Write that down. Now that might say, oh, that's just nitpicking. You're just nitpicking. So what if it's only 3% of all the greenhouse gases? You know, we're pumping so much of it into the air, and there's other greenhouse gases we're also pumping into the air. It won't make any difference. Well, let me just try to make a point to you. All right? Although this is by no means the most important one. Let me make a point to you. What you usually see, if you were to look up, and I do this all the time, every year over the last like 5 years, I look up, you do a Google search, and you know, 90% of the stuff that's going to come up is going to be pro-global warming. Like, this is a bad thing. So you see graphs like this all the time, big Pac-Man graphs, and you have this on your paper. This is carbon dioxide produced, okay, by us, the percentage. And notice that doesn't look like 3% to me. It looks like 82%, which is what it is, right? And these are the other greenhouse gases. So, like, how do you argue with that? Geez, that's why we're worried about carbon dioxide, because carbon dioxide, we're pumping a ton of carbon dioxide, 82% of the greenhouse gases we produce. But it's important you realize that that is anthropogenic greenhouse gases. In other words, that's the greenhouse gases that man-made greenhouse gases, human-made for those of you who want to be picky about it, or people-made. All right? Man-made greenhouse gases, yes, CO2 is the biggie, the guy we put the most of that out. However, what you don't usually see is a graph that looks like this. Take a look at this graph over here. You also have this one at your paper. That is a graph of all greenhouse gases. So what's your point? Here's my point. There's CO2. Okay? There's CO2. It is by no means the most important greenhouse gas. You say, well, so what? We're still putting a lot of it out, you know? I mean, that's going to, you know, some of you, when you were looking at that chart, probably were thinking to yourself, yeah, we've doubled the CO2 concentration, and we're going to double again in the next, 50 years, he says. The temperature's going to double, right? That's what you might think. And that's what my first argument against this is, that perspective. And I use this as my example. I just found this graph yesterday. Okay, this is not on your paper. Just watch it. I'll come back to this one in a second. Let's say that's my portfolio. All right, I'm going to retire. I have a 401k. And I've got some stocks, and I've got some bonds, and I've got some other stuff in my portfolio. Now, this is important, and it kind of goes back to my last question. I actually do have a pie chart. I get that every month, every 3 months. I get a pie chart from my investment, my 401k. Your parents probably do too. You've probably seen them laying around on your tables. Now, let's just say that this particular fund I have, Fidelity Small Cap. This is, by the way, no, I just found this online. This is not my thing. but I actually have had Fidelity funds in the past. So this small cap fund I have, let's say it has a great year, and it doubles. It's now doubled in its price. That's how much of my portfolio it made up, right? And that stock doubled in price, or even tripled in price. Am I now a rich man? Has my portfolio doubled? Would I expect, when I go back to this one, that doubling the amount of CO2 I put into the atmosphere would double the temperature change, would double the temperature? No, I wouldn't. Now, that's not a great argument. That's why I'm pointing this one out first. I'm just showing you, but it is an argument, because you're often told this, CO2, we're pumping so much CO2. CO2 is so important. And you see a graph like that, you say, wow, that's scary. But you forget that the vast majority of greenhouse gases are not CO2. Water vapor happens to be the biggest one. Okay, and we don't really control that a whole heck of a lot. All right, we have really very little control over that. Okay, all right, so that's one argument. That's not a great one, but it is A, I guess, in this my notes. Now let's look at the next one, because this is the biggest one. You have to listen to this too. But hold on, let me go back. Start with a little video clip again. This is from a different show. This is not from Al Gore. This is from a thing called the Global Warming Swindle. I'm going to let them explain it first, and then I'm going to show you the notes on it as well. So turn that light off for me for a second. And this is another clip. It'll only be about 5 minutes. All right.
One of the by the evidence opposite of what station of the theory found as Al.
Okay, here we go. Back to Al Gore.
I am Al Gore. I used to be the next president of the United States.
Former Vice President Al Gore's emotional film, An Inconvenient, regarded by many as the definitive popular presentation of the theory of man-made global warming. His argument rests on one all-important piece of evidence taken from ice core surveys in which scientists drilled deep into the ice to look into the history hundreds of thousands of years. The first ice core survey took place in Vostok in the Antarctic. What it found, as Al Gore correctly points out, was a clear correlation between carbon dioxide and temperature.
We're going back in time now, 650,000 years. Here's what the temperature has been on our Earth. Now, one thing that kind of jumps out at you is, do they ever fit together? Most ridiculous thing I've ever heard. The relationship is actually very complicated, but there is one relationship that is far more powerful than all the others, and it is this. When there is more carbon dioxide, the temperature gets warmer.
Al Gore says the relationship between temperature and CO2 is complicated, but he doesn't say what those complications are. In fact, there was something very important in the ice core data that he failed to mention. Professor Ian Clark is a leading Arctic paleoclimatologist who looked back into the Earth's temperature record tens of millions of years.
When we look at climate on long scales, we're looking for geological material that actually records climate. If we're to take an ice sample, for example, we use isotopes to reconstruct temperature, but the atmosphere that's imprisoned in that ice, we liberate, and then we look at the CO2 content.
Professor Clark and others have indeed discovered, as Al Gore says, a link between carbon dioxide and temperature.
Watch carefully now.
But what Al Gore doesn't say is that the link is the wrong way round.
So here we're looking at the ice core record from Vostok. And in the red, we see temperature going up from early time to later time at a very key interval when we came out of a glaciation. And we see the temperature going up, and then we see the CO2 coming up. CO2 lags behind that increase. It's got an 800-year lag. So temperature is leading CO2 by 800 years.
There have now been several major ice core surveys. Every one of them shows the same thing. The temperature rises or falls, and then, after a few hundred years, carbon dioxide follows.
So obviously, carbon dioxide is not the cause of that warming. In fact, we can say that the warming produced the increase in carbon dioxide.
CO2 clearly cannot be causing temperature changes. It's a product of temperature. It's following temperature changes.
the ice core record, goes to the very heart of the problem we have here. They said, if the CO2 increases in the atmosphere as a greenhouse gas, then the temperature will go up. But the ice core record shows exactly the opposite. So the fundamental assumption, the most fundamental assumption of the whole theory of climate change due to humans is shown to be wrong.
But how can it be that higher temperatures lead to more CO2 in the atmosphere? To understand this, we must first restate the obvious point that carbon dioxide is a natural gas produced by all living things.
Few things annoy me more than to hear people talking about carbon dioxide as being a pollutant. You're made of carbon dioxide. I'm made of carbon dioxide. Carbon dioxide is how living things grow.
What's more, humans are not the main source of carbon dioxide.
Humans produce a small fraction in the single digits percentage-wise of the CO2 that is produced in the atmosphere.
Volcanoes.
See, that's another factor that I didn't mention in that previous thing. Not only is CO2 a small percentage of the greenhouse gases, but of that 3%, we're not making all of that. Okay? You're led to believe by that previous Pac-Man graph that 82% of the CO2 is going into the atmosphere is made by humans. Well, it's not true. 82% of the greenhouse gases that men produce, that man-made greenhouse gases, is CO2. But we don't produce 82% of CO2, which is only 3% of the greenhouse gas. So we are actually in control of a small percentage of a gas. That is only a small percentage of all the greenhouse gases. But more importantly is what he said about that graph being the wrong way around, which I'm going to skip ahead a little bit to get to that point. This is just a little cartoon here.
Is Professor of Oceanography at MIT. He was also visiting Professor in Oceanography at Harvard University and University College London. And there are 4 major textbooks on oceanography.
The ocean is the major reservoir into which carbon dioxide goes when it comes out of the atmosphere, or from which it is re-emitted to the atmosphere. If you heat the surface of the ocean, it tends to emit carbon dioxide. So similarly, if you cool the ocean surface, the ocean can dissolve more carbon dioxide.
So the warmer the oceans, the more carbon dioxide they produce, and the cooler they are, the more they suck in. But why is there a time lag of hundreds of years between a change in temperature and a change in the amount of carbon dioxide going into or out of the sea? The reason is that oceans are so big and so deep, they take literally hundreds of years to warm up and cool down. This time lag means the oceans have what scientists call a memory of temperature changes.
The ocean has a memory of past events running out as far as 10,000 years. So, for example, if somebody says, oh, I'm seeing changes in the North Atlantic, this must mean that the climate system is changing. It may only mean that something happened in a remote part of the ocean decades or hundreds of years ago, whose effects are now beginning to show up in the North Atlantic.
Okay, so let me show you, turn that light back on now. The fundamental assumption, I told you, and I don't think anybody would argue this. I don't think Al Gore would argue this. The fundamental assumption of this, at the time that he was showing that in his movie, he wouldn't have argued it anyway, is that these guys are so well linked together, so well correlated, they must be related, okay? And his argument was, when CO2 goes up, temperatures follow. You just saw the exact opposite. No one ever said this to you, did they? Did anybody ever tell you that the temperature goes up first and the carbon dioxide follows it afterwards? How can carbon dioxide be driving temperature change if the temperature is rising and then 800, 600 years later, the CO2 rises? Can't. It obviously cannot be. It disproves. I've said before, you can't prove a hypothesis. You can't prove any theory. Many laws are changed, but you can't disprove one. That that graph alone, which appears to prove Al Gore's statement, which is the same kind of graph he showed you a little while ago, right? Actually shows the exact opposite, doesn't it? It actually shows the exact opposite. If you look at it and you tease it out and you expand that out and you see that it was actually the CO2 that rose after the temperature rose. And the reason being, I gave you that little part, is because water, you all know this. You open a warm soda, it doesn't dissolve as much CO2. A cold soda dissolves more, right? So the ocean's being warmer. As the ocean's warm, you are absolutely going to get less CO2 being able to be dissolved in there, and it's released into the air, and that's why CO2 goes up. Well, how do you argue against that? Well, I've tried looking for good arguments against that online, and all you hear is, well, it's true that the temperature does rise before the CO2, but the CO2 acts as a positive reinforcement feedback mechanism, and that's why it goes up. So, I mean, I've not found a good answer. I've not found a good answer for what originally caused the warming and cooling. And by the way, if we take a look at this, he made fun of the people who, let me do my best, Al Gore. There are those who will say that's a cyclical phenomenon. You heard him saying those exact words? It is a cyclical phenomenon. You got to be an idiot not to see this. There were no human beings around, burning fossil fuels 300,000, 600,000 years ago, which he said. It is cyclical. It's clearly cyclical. Look at up, down, up, down. He even called this an ice age. He called that an ice age. He called that an ice age. Those are called ice ages. And where would you rather live? With a mile of ice above your head in New York City? Or today, which is where we are right here? That's a big question. That's a good question. I'd rather live now than down here. I don't want to be hunting mammoths in downtown Manhattan. I want warmth. Warmth is good. It has always been associated with more life, the warmer areas, than the ice ages have been. Okay? But besides that, it is clearly a cyclical phenomenon. It is. Now, what caused these? Well, that's a much different story. Why we have ice ages, why we have warmer and cooler periods over the course of hundreds of thousands of years. Can it possibly be due to man-made global warming gases going back 600,000 years? Can it possibly be it? No. Obviously can't be. So this is, not due to us, clearly. Also, this graph. So that's one way this graph disproves his thing. But the other way, when you tease it out, the temperature rises first, and then the CO2 comes up. All right. Finally, if I were to look at this graph and I were to ask you, where will we be 10,000 years from today? Would you say, looking at this graph, up here? Or would you say, down here? What do we have to be more worried about? Do we have to be more worried about global warming? Or do we have to be more worried about, in the coming future, the next ice age? Good question. And that used to be the question asked in the 70s, which I will show you at the end of this presentation, at the end of probably about 2 days from now. All right, so write this down. Well, I can't write it down. CO2 does not drive temperature change. CO2 follows temperature change. This is the second argument against his statement. Warmer oceans simply can't hold as much CO2 as a cold ocean. So when the world rises and when the world warms up and cools down, which it does naturally all the time, okay, it has to do with the sun. It has to do with our orbit. It has to do with probably 1,000 other things that I'm not a geologist and I can't tell you. Some people talk about the magnetic core in the core of the Earth changing, and there's all these theories. But mostly it has to do with the sun and the wobble of the Earth and that kind of stuff in the orbit around the sun and the sun itself. The sun itself has higher and lower areas of activity. We'll talk about that too coming up really soon. But my point is, for whatever reason, over the course of hundreds of thousands of years, temperature does change, and it's CO2 that follows that temperature change. It does not lead it. It does not drive it. Okay? All right. Now, next statement. Next little thing here. Oh, hold on. Your next paper is the next. You just that one there? Okay, I'm going to go back to that. All right, hold on a second.
is that they predict
Okay,
that
turn
as
light
you
on,
go
please.
up through the atmosphere, except in the polar.
Next, ready?
One of the problems that is plaguing the models is that they predict that as you go up through the atmosphere, except in the polar regions, that the rate of warming increases. And it's quite clear from two data sets, not just satellite data, which everybody talks about, but from weather balloon data, that you don't see that effect. In fact, it looks like the surface temperatures are warming slightly more than the upper air temperatures. Oh, that's a big difference.
That data gives you a handle on the fact that what you're seeing is warming that probably is not due to greenhouse gases.
That is, the observations do not show an increase with altitude. In fact, most observations show a slight decrease in the rate of warming with altitude. So in a sense, you can say that the hypothesis of man-made global warming is falsified by the evidence.
So the recent warming of the Earth happened in the wrong place and at the wrong time. Most of the warming took place in the early part of the 20th century and occurred mostly at the Earth's surface, the very opposite of what should have happened according to the theory of man-made global warming.
Okay, so let me go over that. This is a small clip this time. Turn that light back on. The next statement, the next argument, and again, this is the biggest one. This number 2 is the biggie, okay? I think everybody would probably agree with that. But the next one, here, that temperature change and CO2 emissions, and this is already written for you on there. I just added this paper this year. Basically, they happen in the wrong time and the wrong place. You know, they use these models. They're all these models to be able to predict the temperature change over the course of the next decades in the future. And these computer models show all kinds of stuff that they love touting all the time when they want to scare you. You know, 20 years from now, this is what the temperature is going to be. Oh my God, you know, it's going to be terrible. But what they don't say is none of those models have been correct about pretty much anything. They haven't predicted. I mean, granted, it's hard to tell because they only started maybe 10 years ago or 15 years ago, depending on how good they've refined them over the years. But for the most part, they have not been very accurate in two ways. They haven't been very accurate because most of the warming, if you look at CO2, and this graph I'm going to show you in a second, did not occur. It doesn't really follow what happened in the 20th century. It did not occur when it should have, according to CO2 levels. And we're not surprised by this now because we know that CO2, just having looked at the fact that the oceans are changing, are often a delayed response, the amount of CO2. This shouldn't surprise you or me. But it does surprise them because they really believe there's a one-to-one correlation between CO2 and temperature, which is incorrect. So if I take a look at this graph, and you have this graph, I know that paper in particular came out very light because it was in red and blue. They don't actually show up very well on your papers, but you can see the graph, right, for the most part. All right, let me show you what happened, what I'm saying here. Here's what I'm saying. If you take a look, all right, in red is the temperature and in blue is the CO2. Take a look at this. From here to here in red, look at how much temperature increased in the first part of the 20th century. Meanwhile, CO2 levels barely went up. CO2 levels after World War II, look what happens to them. They go way up. Look what happens to temperature after World War II as the CO2 is going way up. It's going down. Okay? Now, granted, this is, again, a not so great argument. Because if you're looking at it, I know it's a not so great argument, and I can say that. All right, I can say that because I know that CO2 is not going to be directly a one-to-one correlation between temperature. But they want you to believe that. When Al Gore showed you that graph, he clearly wanted you to believe there's a one-to-one correlation between CO2 and temperature change, and it was the CO2 driving it. If the CO2 is driving it, why did the CO2 go up? I'm sorry, the temperatures go up this much, and yet we were hardly producing any more CO2 here than we were before. And then, this is a key here. I'm going to talk about this later in the couple of days from now. Temperatures dropped dramatically up into the 70s. They actually did. Like when you go from here to here, right down there, you know what they were calling it? we're going into the next ice age, because people are so short-sighted. They're just looking at a small data set from here to there. Oh my God, next ice age is coming. In your lifetime, they've been looking at this data set. Oh my God, we're frying the earth. You can't do that. Climate doesn't work like that. You don't look at 10, 15, 20, or even 100 years. It's nothing compared to what the oceans are releasing when they're warmed. It takes hundreds of years to warm an ocean or cool it. So these little data sets, and by the way, I'll say this. I know it's going to come up later. You go on the websites for the other cranks on the other side, and they'll say, there's been no warming in the last 15 years. Because if you look at, start here and you go out to 2013 or whatever the last date, it's pretty much level. Or, it hasn't really changed. But again, that's false too. That's not really false, it's deceiving. You can't take a small data set and say that proves anything when you're talking about climate, which is clearly going to change over the course of millennia. All right, hundreds of years, thousands of years, even millions of years. Okay, all right. So, but however, it is another argument against it. There is no one-to-one correlation between CO2 and temperature. All right, in time or in place. Turns out the warming's happening in the wrong place. According to their models, which they want to tout whenever they want to scare you about how bad it's going to get, and whenever it happens to have anything that happens to come up right, they neglect to tell you that for the past 15 years, every model has said we should be getting warming, a lot more of it, a hot spot in the upper atmosphere. And what we found through both sets of data, satellite data and weather balloon data, that's not happening. That hot spot, and by the way, again, this is where places, because it's a color, didn't really show up well on your paper. That hot spot that's predicted by almost all the climate models, all the computer models, this is reality. This is what they found over the course of the past 15 years. It just isn't there. It should be there, according to their data, according to their theories. It's not there. And again, I've said this before about when I was talking to you in Chem 1. You can't prove a theory, but you can falsify it. If you have this much data that was against a theory, you would think there'd be somebody out there saying, well, maybe the theory's wrong. Maybe the theory's wrong. I mean, we have CO2 leading by hundreds of years. I'm sorry, temperature leading by hundreds of years CO2. That's a big fact. We have a cyclical change over the course of, and Al Gore says there's no cyclical. This is clearly beyond that. We have computer models predicting hotspots that aren't there. And these are things that you would think, well, gee, maybe I should rethink this. Maybe there's something else going on here. And some people have rethought it. But those are the people you don't hear about. We're going to talk about that next one here. Okay? All right. But here, that one's going to be actually in a second. I have them out of order. Better go back to this one here. Slide again. Okay, so my question becomes, if it's not CO2, does something else correlate better than CO2 with temperature? Let's check this one out. Okay.
Despite the huge resources of the official Met Office, Corbyn's new technique consistently produced more accurate results. He was hailed in the national press as a super weatherman. The secret of his success was the sun.
The origin of our solar weather technique of long-range forecasting came originally from study of sunspots and a desire to predict those. And then I realized it was actually much more interesting to use the sun to predict the weather.
Sunspots, we now know, are intense magnetic fields which appear at times of higher solar activity. But for many hundreds of years, long before this was properly understood, astronomers around the world used to count the number of sunspots in the belief that more spots heralded warmer weather. In 1893, the British astronomer Edward Maunder observed that during the Little Ice Age, there were barely any spots visible on the sun, a period of solar inactivity which became known as the Maunder minimum. But how reliable are sunspots as an indicator of the weather?
I decided to test it by gambling on the weather through William Hill against what the Met Office said was a normal expectation. And I won money month after month after month after month. Last winter, the Met Office said it could be or would be an exceptionally cold winter. We said, no, that is nonsense. It's going to be very close to normal. And we specifically said when it would be cold, i.e. after Christmas and February. We were right, they were wrong.
In 1991, senior scientists at the Danish Meteorological Institute decided to compile a record of sunspots in the 20th century and compare it with the temperature record. What they found was an incredibly close correlation between what the sun was doing and changes in temperature on Earth. Solar activity, they found, rose sharply to 1940, fell back for 4 decades until the 1970s, and then rose again after that.
When we saw this correlation between the temperature and solar activity or sunspot cycle lengths, then people said to us, okay, it can be just a coincidence. So how can we prove that it's not just a coincidence? Well, one obvious thing is to have a longer time series or different time series. Then we went back in time.
So Professor Friis Christiansen and his colleagues examined 400 years of astronomical records to compare sunspot activity against temperature variation. Once again, they found that variations in solar activity were intimately linked to temperature variation on Earth. It was the sun, it seemed, not carbon dioxide or anything else, that was driving changes in the climate. In a way, it's not surprising. The sun affects us directly, of course, when it sends down its heat. But we now know the sun also affects us indirectly through clouds.
Okay, so I'll let you watch this other part too in a second, but I just wanted to point out to you, it is an amazing thing. I think this is probably one of the biggest problems with the global warming community, people who believe this. Like almost everybody today, we have an incredible hubris. You know what that means, right? An arrogance about our own abilities. If only in this day and age could we believe that us little ants crawling around on the surface of this planet could possibly affect the climate of it. When we got this huge ball up in the sky, all right, the sun, all right, and which has been driving our climate for basically, by all data says, clearly been doing that forever. But yet we think because we're burning a few more trees and we're digging up some fossil fuels that we have the ability to affect the planet. And it's an amazing thing how arrogant we think we are, how important we think we are, when in fact we are a speck of dust. The Earth could swallow, the sun could swallow the Earth and not even burp. I mean, we are just not that big a deal. It's not that, we don't have that much of an effect. And the most obvious thing, if someone were to ask you hundreds of years ago, you were going to ask a caveman, why is it warm or why is it cool? He'd point at the sun. Yet it took us, it's because we're not driving a Prius, or because you're driving your SUV. That's why the Earth's warmer today than it was last week. And that's how stupid we are. We are incredibly arrogant when it comes to stuff like that. And it's just a fact. But anyway, let me show you another way that that the sun can affect it besides directly. What we have been, by the way, in a relatively inactive period for the sun over the past 10 or 15 years, which is why temperatures have not risen. They really haven't in the last 10 or 15 years gone up very much.
Clouds have a powerful cooling effect, but how are they formed? In the early 20th century, scientists discovered that the Earth was constantly being bombarded by subatomic particles. These particles, which they called cosmic rays, originated, it was believed, from exploding supernovae far beyond our solar system. When the particles coming down meet water vapor rising up from the sea, they form water droplets and make clouds. But when the sun is more active and the solar wind is strong, fewer particles get through and fewer clouds are formed. Just how powerful this effect was became clear only recently, when an astrophysicist, Professor Neil Shaviv, decided to compare his own record of cloud-forming cosmic rays with the temperature record created by a geologist, Professor Jan Weitzer, going back 600 million years. What they found was that when cosmic rays went up, the temperature went down. When cosmic rays went down, the temperature went up. Clouds and the Earth's climate were very closely linked. To see how close, you just flip the lines.
We just compared the graphs, just put them one upon the other, and it was just amazing. Jan Weitzer looked at me and said, you know, we have very explosive data here.
I've never seen such vastly different records coming together so beautifully to show really what was happening over that long period of time.
Okay, so. All right, so here, take a look at this graph. This is the last one you have on this paper, right? Turn that light on. Now, I showed you a little while ago how the actual carbon dioxide production did not correlate well with the 20th century. Okay, sunspot activity, however, does. Solar activity does, and so does the cosmic rays activity, which is again controlled by the strength of the sun. Correlates very well over the course of hundreds of thousands, millions of years, and over the course of this century. You saw, look here, we had a very little rise in CO2, yet a strong rise in temperature. And then when CO2 went up, temperature went down. That didn't correlate well with CO2, but it correlates very well with the solar activity, right? So the last one on here, and the last one I'm going to talk about today, is solar activity and other factors correlate better. When I say other factors, I mean stuff like cosmic rays, and there are other factors as well that are going to correlate far better than CO2 does with temperature change. Now, I won't spend as much time on the future ones. All right, this is a biggie, though. All right, because what I'm really talking about here, the very fundamental assumption that CO2, if you look at back at your very first page here that I gave you, CO2 drives temperature change. If that is correct, then we should all worry. If it's the factor, if it's the major factor, if it's a factor at all right, we have to worry a little bit. But if it's the major factor and it's driving on a 1-to-1 ratio, like Al Gore would kind of imply, and it's going to be responsible for huge increases in temperature and vast melting of ice, we need to be worried. All right? But I think these first four things show that this is simply not the case. CO2 follows temperature change, not leads it. CO2 is not correlated as well as other factors like solar activity and cosmic rays. All right, and all those other things I mentioned over the course of these four reasons why. So there's my summary, okay? And CO2 is only 3% of all greenhouse gases, and man-made CO2, man-made, stuff that we can control how much, a small fraction of that 3%. We could stop burning everything tomorrow. CO2 is still going to be there. It's still going to be produced by 1,000 other natural ways. CO2 follows temperature changes. The temperature change and CO2 are not correlated well, either in time or place. And where they are correlated, they follow it. And solar activity actually seems to contribute much more. Okay, so that's my little summary. Now we're going to do the other ones a little faster than that one, but I want to spend most of my time on that one because that's the key. That's the biggie. Okay.